All right, so do a whole lot of new stuff today. We'll go through some papers that kind of all relate to a similar topic. We'll then look at, start out with some stuff that looks kind of similar to the homework. So I got those graded. What I would suggest, kind of after going through those and thinking about next week's exam, make sure you're always err on the side of being too detailed, right? Always err on the side of kind of like including everything that you can think is possibly necessary, right? And explicitly kind of stating things as opposed to like just assuming that I'm going to pick up from what you do. I don't know, just being very deliberate in kind of what you do. I put up a practice exam. So midterm practice folder, I've got it kind of up there with some solutions. I've actually got homework 2 solutions. I just writing through them. I read one of the questions wrong, so it's not quite right. So I just have to update one of them. I'll get those scanned and kind of uploaded to Canvas. So you'll have those 2 answer keys for both homework assignments. Those will be good things to go over for the exam. Also, that set of practice problems, and then we'll kind of keep working through stuff Monday and Wednesday of next week. I think what I'm going to do is on Wednesday, I'm going to create something on Canvas where you can access it on Canvas so that once you open it up, you'll see the exam. You'll then have like 2 hours to then upload your work. If you want to take it in class, I guess, in person, like I'll be here Friday. And you can let me know. I don't know why anyone necessarily would want to sit down and take it in class for an hour when I give you 2 hours to, you could sit in your apartment or have all your materials in front of you. Which means that it'll probably be kind of similar to the homeworks, but maybe a little tougher, right? If you've got access to everything in front of you, a pretty good amount of time. But yeah, I'll probably open it up after we do our last review on Wednesday's class. So you can do it Wednesday night, Thursday, Friday. I'll probably even leave it open to the end of the weekend, right? All the way through Sunday. I don't know if, some people might be leaving, traveling. So you've got kind of a good number of days to upload or to access that and then kind of upload your work. Okay. Yeah.
Sorry if I missed it. How many questions did you take?
I didn't say. So I'm still fine tuning it. But it'll be like 10 to 12 multiple choice, and then like 4 or 5 short answers that have multiple parts. It kind of depends on how many multiple parts I add to certain questions. I might only have 4 instead of 5 or something like that. But I don't think time should be a big issue with it. Obviously on the short answer, like just similar to the homework, show as much of your work as possible. You should probably have a graph, or if I, will ask you for a graph, for most of the short answer, you'll probably have something kind of drawn out as well. Okay. So in that event, some of the mistakes that I noticed are on the homeworks. We'll kind of go through a couple similar examples today, and I might throw in some additional stuff that wasn't on the homework assignment, so we'll get a little more taste of this. So here is kind of like a pretty good example of a question you could see on the exam, where I ask, give you some consumers demand curve. Here, I believe this is actually the same one that we had in the homework assignment. But I wanted to kind of go through, what's the highest price consumer is willing to pay for a single ticket. So there's a little bit of confusion on this one, right? But if we want to know the how much someone's willing to pay, that comes from that demand curve, right? So we would just plug in that quantity of 1 times 15, 150 minus 1 times 15 is 135. It's as simple as that one would be. Now, when it comes to something like figuring out if I'm doing some quantity discounting, it should also be just as easy. So if I think about what I've got here, just visually, I've got this representative consumer. I know that my demand equation starts at 150, right? And I can actually figure out where it hits my x-axis. So how could I figure out where it hits the x-axis? Well, this is the point where this demand would be equal to 0, right? So if I set this equal to 0, and then do a little bit of algebra to solve for Q, I get that the demand curve hits my x-axis x-axis at 10, right? Now, I want to do quantity discounting, right? We kind of already said, well, for the first ticket, right, I would plug in a quantity of 1. So for that first ticket, my price would be $135, right? If I could charge a different price for every single ticket purchase. I could then say, okay, how much would they be willing to pay for that second ticket? Well, it's as easy as, taking that quantity of 2, plugging that into my demand equation, and I get a price of 120, right? I could then kind of keep on doing that, right? Every single additional ticket purchase, like it's just dropping by a price of 15. So that's the idea of quantity discounting. All I'm doing is plugging in each quantity into that demand equation to figure out what that corresponding of willingness of the consumer to pay is, or what the price I could charge is. Any questions on that? So I think the next one asked, and I'll make this one a little bit tougher, I think, than the homework. So I think in the homework I said, how much will you charge for a block of 10 tickets? Right here, I'll do it a little bit different. Let's say I was selling a block of 5 tickets, right? Thinking about this is kind of like season tickets, or 5 doesn't make a lot of sense here, but you can imagine however many games, right? I might sell that number of home games, right? So here we'll just assume I'm selling these tickets in blocks of 5, right? What's the one-time fixed fee I could charge a consumer to buy that block of 5 tickets, right? Well, you can think about it's going to be however much they would benefit, right? The consumer surplus. Well, of attending the game, once I have these tickets, the marginal cost is essentially 0, right? Once I pay this fixed fee, right, now I can choose to go to any of these 5 games that I have tickets for. The marginal cost is 0. So the entire consumer surplus would be the area under the demand curve up to that quantity of 5, right? Whatever that block of tickets I'm selling is. So here it becomes a little bit trickier even than the homework. I think the homework I said a block of 10, so you just had the area of a triangle. Here I've got kind of like 2 areas, right? So one is going to be the area of this triangle. The other is the area of this rectangle. So I need to figure out, okay, well, what point am I at here, right? Well, that's just the point I'm at on the demand curve at a quantity of 5. So figure out that is 75. Now it's just a matter of finding the area of a triangle, adding that to the area of a rectangle, right? So I would do what? 150 minus 75 times, goes from 0 to 5, so times 5, oops, times 1/2. That'd be the area of my triangle. And I would add to that 75 times 5, or the area of my rectangle. Okay. I don't know what this ends up being off the top of my head. So this is what? 75 times 5, 350, 375, 7. No. Anybody want to help me out? 375 and then half of 375 added to it. So it's whatever that is, it's 500 and something. Any questions kind of on that idea? Yeah. So, right, the entire area under my demand curve is going to be consumer surplus. Because essentially, once I buy this block of tickets, the marginal cost of attending the game is essentially, I mean, we could build in a more complicated model, but you're thinking about, if it's not during work hours or something like that, there's kind of 0 marginal cost to attending the game. So I think like I said, in the homework, I asked you, I was selling a block of 10, which then it just became the entire area underneath my demand. Any questions on that one? Let me think if anything, something else I wanted to say here. So we've got thinking about this. Oh, what's the last? Let's see, other questions that I have on here. So we got kind of this quantity discounting. single price monopolist selling it to big guy. So the other thing that we can do, kind of similar, and most people got this pretty correct, but I just want to kind of go through it quickly here. So let's say we have that same demand curve. All right. And we're thinking about what price would a single price monopolist set. We know that marginal revenue will be twice as steep, right? If we're dealing with a monopolist, they make decisions based off of this twice as steep marginal revenue curve if they're setting a single price, right? So if we have our demand equation, I know marginal revenue is going to be that, but twice as steep. So instead of 15Q, it's going to be 30Q. So what I want to do in this model, right? I've got kind of, you want to think about my seats, like marginal cost run all the way out to whatever capacity is. If I'm making decisions for an individual consumer, they're never going to have a high enough demand to ever meet that capacity. So all I want to do is figure out where does marginal revenue hit that x-axis, right? I do a little bit of algebra. I get that would be at a quantity of 5. You actually can already know from our previous work at a quantity of 5, where are we at in our demand curve, or what price could I get away with charging? Well, go back up, plug 5 into my demand curve, and I get 75. All right. So, and think about here, if I was a single price monopolist, I'm going to charge $75 for every ticket, and I'm going to sell, the optimal or the number of tickets that I'm going to sell these represent consumers will be 5. Right? So I can compare that to even what I just did with the block of tickets, right? So here, how much total revenue have I generated? So total revenue is total revenue is not quite the same as surplus, but we think about total revenue is just price times quantity, right? So here, 5 times 75. Right? I think this is what, 375. And then I could compare that. Well, if I sold this block of tickets, I could kind of charge the entire area of the demand curve. So like for that first ticket, instead of selling it for 75, I can kind of extract more of that consumer surplus. So whatever this ended up being, right, whatever that total kind of area under that curve was, that's the amount of additional, or that's the amount of revenue I can make selling a block of tickets. I could then compare that to the amount of revenue I made selling at a single price for each ticket and say like which one's greater. What ends up always being true. I mean, here we kind of got a nice visual. You can think about, here's my total revenue. Well, what total revenue did I generate if I sold a block of tickets? This entire area, right? So by selling a block of tickets, I can extract more consumer surplus. Any questions over anything there before I keep moving? Okay with that? All right, so the other one I want to go through, skip that one for now. So I want to go through more of kind of this minimum and maximum, because I saw maybe a few more errors with this. Really kind of hit this home, and I'll actually throw in some stuff, combine two things we've talked about, but I haven't really combined them yet, or I haven't shown you an example of combining them yet. So here I've got large market teams targeting 55 wins, small market teams targeting 35. Assume that both are profit maximizing, right? So, and then we're going to talk about like how can we use salary minimums and maximums. So I have to be a little bit more, I was a little more explicit in the homework because we had multiple scenarios. And I told you that like the win maximizing point for small market teams was greater than that for large market. The win maximizing point for small market teams was greater than the profit maximizing point for large markets, right? So what that let me know is if they both face the same marginal costs, right? And I've got, here's my small market, where marginal revenue is equal to marginal cost. That's going to be sorry, use different notation. All right, profit maximizing number of wins for the small market team. I then have, draw this in a different color. Actually, let me think about this. So we'll go, here's my marginal revenue for my large market teams. Here's the demand, right? So there, profit maximizing point is going to be higher. I think the numbers I gave, right, were 55 and 35 or something like that. They're both profit maximizing, but we could also kind of go through some scenarios where they're win maximizing. So that's why I'm kind of including the demand curves as well. So we'll get to that in a second. But for now, they're both profit maximizing. Where can I set, or where would I want to set either a salary minimum or maximum in this league, right? So I could actually use both, right? So which one would be preferred? So let's go through thinking about each one. If I set a salary maximum, where would it have to be below? It would have to equate to a number of wins. If I'm trying to improve competitive balance, below here. If I set a salary maximum way out here, well, the team's currently spending a lower amount. They're like, okay, who cares, right? We're not spending that much. We're not, that cap's not going to be affected. So we know that it has to be set below whatever that large market team's number of wins are here. Now, if I set a maximum here, right, what's that going to do? So if I use a maximum for my small market, what's going to happen to the number of wins? Nothing, right? It's not effective, right, at changing there. So wins kind of remains the same, right? What about for the large market team? Yeah, it's going to decrease it, right? It was previously spending over that cap, so they're now going to have to not be able to spend as much money and kind of end up targeting a lower number of wins. So I've improved competitive balance, but I've lowered kind of the overall quality, right? I've lowered the how much each team is actually going to be putting forth towards spending money on their players, right? Spending money on increasing their quality. What if instead I used a salary minimum, right? Where would I want to set that? Yep. And in fact, where could I set it? I could actually set it even higher. So if I'm interested in just improving competitive balance as much as possible, if I set my salary minimum here, it won't change anything for the large market teams, but it would push my small market team's number of wins all the way up to be exactly the same as that large market, right? Now, in this model, I can do that because I know there's still positive profits, right? They haven't got to the point where the demand curve hits marginal cost or where we said profits were equal to zero. So in fact, so before I go there, sorry, I'm jumping the gun. So if I set a minimum, if I set it right at that large market, I've done like nothing to their wins, but I've increased competitive balance and I've increased the number of wins. So which one would be preferred here? Well, if I use a maximum, I'm just decreasing the quality of my league. And yeah, I'll have good competitive balance, which will boost demand. But here I can get the same effect, boost competitive balance, right? Get it to be exactly the same for both large and small market teams, but improve the overall quality, right? And in fact, if I was interested in not just improving competitive balance, but also increasing quality the most, what's the highest point I could set that minimum to? Whatever that small market teams win maximizing number of wins would be, right? Now, I've forced both large and small market teams to increase the number of wins, but they're targeting the exact same number. So I've maximized competitive balance, right? The gains I could get from that. And I've also maximized kind of the increase I could see in quality for my league. Any questions? Does that make sense? Any questions on that? Okay. Now, this won't always be the case. Like if there was a big enough difference, like the demand for large market teams is way over here. I don't have kind of this point where win maximizing small market is greater than the profit maximizing for large. Then some of the implications will be a little bit different, right? But because I can never push a minimum past that point where profits are equal to zero. Because if I push that minimum out further and make them spend even more money, they're going to have negative profits. What's going to happen? They're going to leave the league in the long run, right? So I can only ever kind of put my minimum up to the point where I'm forcing profits to be exactly equal to zero. So with that in mind, I won't do a large small market thing here, but I am going to, and I don't think I brought enough paper, so hopefully I can conserve a little bit. Let's say I'm just looking at, well, I can do both actually. So do constant marginal cost. Let's do demand for large market, marginal revenue for the large market, and then demand for the small market, marginal revenue for the small market. Okay. But let's say that there's some revenue sharing in this league. Now, these are what the demand curves would be like after the revenue sharing. So I'm not going to draw the shifts in. But what I would have to draw in is if I have some revenue sharing going on, I'm also going to have average total revenue curves that aren't the same as my demand curve anymore, right? They're going to be a little bit higher. Now they'll approach the demand curve as I get a higher number of wins. I'm going to think about it as the average total revenue. If I'm getting a lump sum, well, the more games I win, the amount of revenue I'm getting per win is going down, right? Getting closer to kind of that, where that demand curve would be. I could also think about, I might have the same thing for the large market team, right? So they're getting an amount of money back from the league as well, right? Whatever was paid into this huge pot, kind of distributed back to every single team equally. So here, let's, doesn't matter, I guess, per se, whether or not, well, what do I want to do here? So let's say, we'll start out with the same scenario where both teams are profit maximizing. If I wanted to use a salary maximum here, right, where would I want to kind of set that salary maximum? Somewhere below where my large market teams are currently targeting their wins, right? If I'm trying to get them so that they're decreasing the number of wins, I'm going to have to use a maximum that's somewhere below this. So hopefully we're going to get this idea that if I use a salary maximum, which one would actually set the highest competitive balance? Setting it all the way down here, right? The only problem is, no matter where I set it, we have the same implications, which is that doesn't affect the small market teams. Large market teams decrease the number of wins. And yeah, we've got improvements in competitive balance, but we've got a decrease in quality, right? So hopefully we can kind of see here, like, you know, a lot of times these maximums, while they do improve competitive balance, they're probably not as really effective as at creating a better product as a salary minimum would be. So if I wanted to instead set a salary minimum here, where is the highest, or what would be the highest level I could actually set this minimum at? Well, by setting a minimum, I'm trying to increase the number of wins that this team is targeting. I could go here, 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 all the way out to the point where profits are equal to zero, but I now have this revenue sharing, right? If profits are equal to zero at the point where my average total revenue curve hits that marginal cost curve. As long as we have this kind of constant marginal cost. So this salary minimum increases the number of wins that small market team targets, decreases the number of wins, or sorry, not decreases, doesn't change the number of wins, and we've improved competitive balance. Right? Any questions on this? Now, there could be one argument, if I'm using these salary minimums, why might it actually have a long-term negative effect? Well, if I truly set this salary minimum exactly where profits are zero, those small market teams, right? They're not storing up any wealth, right? To kind of spend down the road, right? And so maybe there's an argument there that you wouldn't want to do that. But if we're just concerned about competitive balance currently, right? Using those minimums, we could achieve better, improved competitive balance while also kind of improving the number of wins, right? And now here, okay, well, I still have closed the gap. Let's say I use both a minimum and a maximum. I've closed the gap, right? I've improved competitive balance in both directions. And yeah, the number of wins from the large market team is going down, but the number of wins from my small market team is going up. If I wanted to kind of set a minimum and a maximum, that all I was concerned with, not the quality of my league, but just improving competitive balance, what would I actually do? I'd set the minimum and the maximum at the exact same point, which is where the small market team would have profits of 0. Okay. Any questions on that before we keep moving? I want to point one more thing out too. If I'm using this maximum, what's happening to the large market team's profits? Good question. Yeah.
So is there a reason they don't just teams that consist or like small market teams that consistently just profit maximize? Is there a reason they don't just drive them out of the market?
The league?
Yeah, damaging
their
the overall
product. Yeah, I mean, my guess is they wanted, having a higher supply is good, because if you think about, it's not really just the national market, right? If you can get a team in different cities, you're opening up an entire different consumer base, right? So they like to have probably as many teams in large cities as they can get. The issue is, why would you not want to drive them out? Well, I probably would try to do other things to increase their performance, like reverse order draft, right? Maybe put in some league minimums, right? I probably would try to do all these other things to force those small market teams to move away from the profit maximizing kind of behavior point, closer to where a win maximizing point would be for them. Is that
like a reverse order draft?
Mhm.
You could draft, and then trade away to
if they want
cheaper.
Yeah, you're right. If they wanted to, they could always kind of resort back to that profit maximizing behavior. The salary minimums is one way you could shut that down, right? Like requiring you to spend a certain amount of money on players because what are the two options there? If you have to spend the money on players, I guess you could argue they just pay bad players even more money. But why would you choose that option when you have to spend the exact same amount, you could get better players, right? So like you're kind of guaranteeing that like these teams, if you force them to spend some of this money that the league's giving them, then you're kind of ensuring that they're going to at least see some improvement. But yeah, there's no it's hard to resolve this this issue, right? It's hard to resolve this large small market issue, or even if there isn't a big difference in your markets, it's hard to resolve win versus profit maximizing behavior issues, right? Even if you've got two teams of the exact same size, every single team is has the exact same size market in your league, but some are profit, some are win maximizing. All you can do is create incentives that would, or I shouldn't say incentives or regulations that would require them to kind of choose behaviors that would move that target number of wins higher. That's not like I said, it's probably not a great answer in terms of like, if I had a fix for it, I probably wouldn't be here. Right. If I could envision kind of what that would be. But something like this would help, right? You could also imagine like, if I'm a profit maximizing team, maybe there is something I could set up to where the league could create additional. The problem is that it's a sport and people aren't going to view it as fair. One way to really solve this would be, I can identify the teams that are smaller markets, and I only offer those teams additional incentives if they make the playoffs or if they win a certain number of games. But like, if I don't offer those same incentives to large market teams, now people are like, well, now you're treating the teams unfairly, right? Well, it's kind of unfair to begin with, right? The one team's working with a much larger market than the other, but you'd have to do something like that where it would only apply to your small market teams, right? Not currently aware of any. There might be some rules in some sport that that, that tries to do that. Like if you have ticket sales under a certain amount, maybe they create additional incentives or something. You could do something like that, but I'm not like aware of any professional sports doing that. Is that kind of?
I mean, yeah, I
Yeah.
just don't understand why it's a broad brush over the whole topic and not more individualized.
By the leagues?
Yeah. If
Yeah,
there's such an
I
issue
mean-
with competitive balance, why are you taking it?
Yeah.
as every
Well,
team's-
and I might be exaggerating like these differences, right? And when I'm actually looking at, Charlotte compared to New York, there's definitely going to be differences,
Yeah.
right? But the amount of revenue, we think about market size, the amount of revenue maybe that they're making isn't as wildly different, right? Because they aren't just a local market. Even in the Charlotte Hornets, they have fans probably outside of Carolina, right? And so it's probably that there aren't huge differences in their kind of demand marginal revenue curves, but doesn't matter how far the gap is, we know that gap's going to exist. Now why would you not treat? Yeah, I think it's like the reverse. So I'm going off on a tangent, but it's kind of like the reverse order draft. It is odd. That's one situation where you're definitely treating teams differently depending on how they win. Right? So I could say to these teams, if your gate receipts, like ticket revenue, is within this range, right? We will give you a certain amount of shared revenue, but it's not just that we're going to give it to you as a lump sum. What I have to do to make it more of a motivator, if they're truly profit maximizing, we said, if I just give them additional money, what are they going to do? They're going to keep targeting this number of wins and just pocket it, right? But if I make that revenue tied to performance, what I'd essentially be doing is say, like, look, if your gate receipts are below a certain amount, that identifies you as a small market team, right? For every game you win, we'll give you an additional, $100,000. Come up with some additional revenue. Now that revenue is tied to wins, what I've actually essentially done is increase the demand and marginal revenue curve for those smaller market teams. So yeah, why don't they do that? I don't know. I don't work. I know I'm not within the organizations, but if you wanted to look at these different markers for small market teams, and then instead of giving a lump sum amount of revenue, because that's not going to change the behavior of a profit maximizing team, you have to tie the revenue to the performance, right? Just like they tie the lottery pick. It's like, the better pick has a higher value. Could generate higher additional revenue. They're tying that to performance. So why don't they do it in other dimensions? I don't know. I don't know why. I think the revenue sharing programs, are pointless if you don't have win maximizing teams. There's no point in doing revenue sharing if you're just giving a lump sum of money to the teams if they are profit maximizing. So you would want to do something like where you somehow tie it to their performance. Then you're increasing the incentives, the marginal revenue curve will shift out, and then those small market teams, even if they still profit maximize, would target a higher number. Does that kind of make sense?
Yeah, I mean,
It's just why don't they do it, right? Yeah, that's why I don't know. I don't know why they don't do it, right? Because you definitely could create a system like that where you incentivize higher performance for your small markets. Good question on this. So just want to kind of revisit these models. Much time? 15 minutes. So we'll go through down here. So I'll ask a couple questions here. So we'll get these out of the way, and then we'll kind of look at a couple papers along with the one that I had kind of for the reading this week. So skimmed over or read through that paper. Hopefully this shouldn't be too bad. But the paper was primarily about which of the following: hot hand fallacy in basketball shooting, hot hand fallacy in NFL field goal kicking, hot hand fallacy in NFL referee flags, like throwing penalties, or hot hand fallacy in NFL betting. Let's give you a little bit of time. Let's get your answer for this. All right. Make sure you get your answers in here. think it counted 17. All right, yeah, it's not working. Well, there's not a whole lot of people here, so maybe I'll just give everybody credit for it. Got 16 now. Still not going through. All right, there we go. Everybody good? All right. It's probably the Wi-Fi. It's terrible in this building. Okay, so which of these was it looking at? Betting, right? I was looking at betting markets. So we'll kind of get the first kind of discussion of betting today. Just to kind of talk through this one. Which of these would be the dependent variable? Like, even if we didn't read this paper, if I'm thinking about how do I identify whether or not people are betting too much on a team because they've previously won, right? Then what I would want to look at is how are people betting, right? So their dependent variable, their left-hand side variable of interest is going to be, well, what percent of people are betting on this home team, right? We're looking at the home team. If they have a longer win streak, are people more likely to bet on them, right? So the way that kind of betting works, so I'll give, I think I've got some of the results here. I won't pull up the actual paper. What? Oh, come on. All right, I'm not going to touch it. So let's say, so we look at their regression equation. They pulled a bunch of different betting data. So when you set these lines, like for bets, what the companies are trying to do is, so here I think we're just looking at betting on the home team to cover the point spread, right? So when they set a point spread, something like, I don't know, negative 2.5, we talked about this a little bit, means that they're going to win by 2.5, more than 2.5 points, right? So negative means that you're going to win by that much. Positive means I'm going to lose by less than 2.5 points, right? So the way they set these lines, what they're doing is you want to guarantee you're making money as a gambler, right? So what you would like to do is make sure that you're getting a 50-50 bet. So that 50% of people, like this is going to be a 50-50 chance that they win by or lose by less than 2.5 points, right? That way you'll get people to bet, about 50% of people will bet the over, or sorry, the over, or 50% of people will bet the under. If I can guarantee that I've got 50% on either side, it doesn't matter what the outcome of the game is. I'm going to, I know that I'm going to have to pay out a certain amount of money, right? 50% on either side means whichever side wins, I have to pay out half the people, whatever the return is on the bet, right? Now, if I can guarantee that, and I'm taking a cut, then essentially I'm always guaranteeing that, like, no matter what the outcome is, I'm net benefit of 0. And then the other benefit is whatever I'm skimming off the top, right? So even if I make it a 50-50 bet, like if you imagine I'm not trying to make money and I try to set a 50-50 bet, so I got 50% of you to bet on one side, 50% to bet on the other. So let's say you all pay me $1. I don't know. So I get like, whatever, 22 or however many people, $22, but everyone gives me $1. Half of you, I'm flipping a coin. Half of you think it's going to come up heads, half think it's going to come up tails. Well, it comes up heads, everybody who had heads, I pay back out $2, right? Now, then I would pay, $22, so I have 0 money left. But I'm facilitating this bet. So I'm like, okay, you guys give me $1. I'm going to keep 2 of the $22. And then I'll give back, distribute evenly the $20 remaining to whoever won. So that way, it's a 50-50 bet. I'm always guaranteeing that I'm going to make money off whatever I'm skimming off the top, right? Or the amount of money I'm taking for facilitating these bets. Because if I ever go the other direction, like let's say I set a line where 90% of people are on one side. Look, even if 90% of people are wrong, it could be the result of the game, right? That could end up being the result. Now I've got to pay out way more people than 50%, right? And I'm gonna actually have to be eating into my profits, right? So I'm always trying to set, if I'm a betting company, I'm always trying to set lines at 50-50 bets. So as a result, does that make sense? Any questions on that? Trying to give kind of a setup of this. As a result of this, we can think about, okay, the percent of people who are betting on the home team, we're thinking about percent of people betting on the team to cover the spread. If they're, on a win streak, right? How is that gonna change the percent of people that are betting on the team? Well, the thing is, it doesn't matter if the team has won their last 4 or 5 games. Whatever the point spread is set at, it's taking into account all the information. So every week, they're updating what they think the quality of that team is, right? So every week, it's a 50-50 bet. It doesn't matter if they won the previous 4 or 5 games, whatever the line is set at, it's set to be a 50-50 bet. So it doesn't matter what they've done before, they still should have 50% of people betting on either side. So if we see anything other than 0 here, what that means is people are falling victim, like it's like the roulette table, 50-50 every time. But if I see black hit 5 times in a row, well, I'm like, man, this table, it's hot. So maybe they'll hit black the 6th time, right? That would be the idea of the hot hand fallacy. Well, they keep on winning, right? They keep on covering the, so they're definitely going to cover the spread. Well, no, that spread's already factored in that they've been winning. So, if we find a positive effect there, people fall victim to the hot hand fallacy. So I don't think the paper went into this too much, but I'll take it 221. If I found a negative coefficient there, we would call that the gambler's fallacy. That's like a roulette table. This comes up black 10 times in a row. I think it has to come up red on the 11th time, right? If I've seen a team cover the spread 4 or 5 games in a row, if I fall victim to the gambler's fallacy, I think, well, there's no way they can do it a 6th week in a row. Well, no, it's still a 50-50 bet. Right? So they go through, and what they did was they included indicators for what number of win streak the team was on. So they had 1 game, 2, 3, 4, 9, 5 and more. And then they also had kind of, if they're on a losing streak, do people think that they're just more likely to not cover the spread because they've been losing a lot? Well, no, it's always a 50-50 bet. So kind of interesting is, and this isn't quite significant, but win 1 game, the following game, people are more likely to bet on that team to cover the spread. Still a 50-50 bet, still should be 50% on his side. But if they've won the previous game, about an increase of 2%, more people will bet on that team to cover the spread in the following game. And then if we get to a 3-game win streak, well, now people are 5% more of the general public are betting on that team to cover the spread. It's kind of interesting is once we get to these higher values, they're not near as large, but probably what this is being driven by is there's just not as many 5+ game win streaks if we're looking at kind of NFL data. So it'd be interesting to see this replicated, but NBA, Major League Baseball, I can kind of see, okay, we actually do see more 5-game win streaks in these sports. It's harder to kind of pick those up in the NFL. And then I forget what they did in the second model. I think they added in some more some different control variables. They kind of find a similar thing going on, right? Maybe the effects are a little bit larger. They also kind of see, replicate on the other side. If teams are losing more games in a row, then fewer people will bet on them or cover the point spread, right? So if I lost my previous game, there's a reduction of about 3.5% of the public will no longer bet me to cover the spread the following game. And then kind of you can see here, there's a couple that are significant here. Once again, we don't have as many teams on 4 or 5 game losing streaks, so we don't really pick up any significance from those estimates. Let's make any questions on this before I keep going. So they accounted for I don't know, some other, this isn't every control variable. I forget all the control variables that they included, but you would want to try to control for probably the quality of the opponent, right? Or you would try to control for all these other things that you think might make people be more or less likely to bet on this team. But you could set it up a very similar way here, right? So they find evidence that there is some of this hot hand betting going on, at least in NFL betting. There's a lot of betting data out there now, so you can really play around with this. So if I'm thinking about these results, right, and I'm a gambling company, I know that people are falling victim, or at least I have evidence that are falling victim to this hot hand fallacy, right? When I'm setting my lines to be 50-50, do I like this or not? I love this, right? because I know that it should be 50%, or if people are betting more on one side. And because they're factoring in, this hot hand, this team's been on a win streak. I've already factored that into my line, and I'm gonna end up with, on average, more people losing than I am gonna be people winning, right? It should be 50% on either side. People who are falling victim to this, they think the point spread should be, instead of +2.5, it should be +1.5. Well, they're making the error, right? They're actually, gonna be the ones that lose out. So gambling companies love this, right? Because, they're already factoring in, it's a 50-50 bet for them. This is just gonna guarantee more people kind of end up on maybe the wrong side. Right? We start to think about gambling markets. We'll go into more of that after the midterm exam. Yeah.
Wait, so it doesn't matter, like, so say it's 50% on each side, people wise, but what about like total money? Like, what if there's way more money on?
Yeah, so it gets more complicated. I'm talking about it in terms of the percent of people, but you're right. It's not the number of people or the number of bets. It's actually the amount. I want the amount of money to be 50% on either side.
Yeah.
So it gets a little bit more complicated because my guess would be, you see this a lot in betting. Actually, it's like something you can kind of play the stock market. You can only really make money if you know something that somebody else does. All right, you have to. You have to, the stock price already factors in all the things that people can look at. So unless there's something that hasn't factored in that I'm aware of that matters, I can't really make any money. So same kind of thing here. If you look at the general public, like generally, if they're over betting on one side, but then the percent of the total money is on the other side, well, that's telling you it's probably that the people putting big money probably do this for a living, or probably are a lot more in tune with what the lines should be. And so if you see a lot of the money on one side, but a large amount of the public on the other, that probably means they're falling victim, maybe not to the hot hand, but they're falling victim to something surrounding that team that they're incorrectly believing that they're more likely to cover the spread than what the kind of experts are, right? So generally, if you see that occur, you would want to be on the side of, well, where's the money?
Was that where like betting apps will post, like someone will be like 60% of, FanDuel users like took this, 60% of DraftKings users.
Yeah, make it a little bit tricky with it, right? So if I want to guarantee there's 50 people on each side, I mean, you could probably spend some game, but like, let's say I currently have 60% of the money on one side and 60% of the people, right? So just to make it easy. What do I want to try to have? I want 50-50. So what do I start to do? Start to move the line to make people more likely to bet on the other side.
You think that's why like sportsbooks will give you like boost?
I don't know why they do that. I think they do that to keep you on their app more so that you're more likely to make future bets. Because that I've actually, well,
I gotta
Well,
know, like they think like players or like teams are like getting hot. So they'll-
yeah, and I'm also kind of pessimistic view of companies in general, but like my guess is it's kind of like a sale. If something's $100 and I tell you it's 20% off, but it's always 20% off, then the price is 80. If I tell you that the line should be this and then I boost it to be something else, well, maybe that's what it should have been to begin with, right? So that's what I think they're doing, but I can't prove that. I don't know I don't know if that's exactly what they're doing, but that would be my guess.
Playing, he's never had a boost.
I've never.
All right, well, they'll wrap it up here for today.
I don't think I've ever.
Start to kind of look at those practice problems. I'll get the next answer key, homework answer key up, and we'll kind of keep doing some more review Monday and Wednesday of next week. All right. But fun, safe weekend, and I'll see you guys on Monday.